ProTools processes audio digitally as zeros and ones. So in this movie, I want to cover the basics of that. You know which settings are right for the kind of project that you're doing. I want to cover the theory of it now, so when we use the settings later, we can just use them and I don't have to stop and explain what I'm doing. Our ears can hear from about 20 cycles on the low end to about 22,000 cycles on the high end. That parameter is measured in frequencies or hertz, Hertz. Let's take a listen to this. I stop there at about 7,000. It gets pretty piercing as you go up. Frequency means how often does it happen? And you can see on the very low frequencies of this sweep that the peaks are farther apart and they get closer together as the frequency gets higher. And by the time you get back into this area, they appear to be so close together that they're welded, although I can zoom in here and make them look like the beginning. Now at that zoom level, if I jump back to the beginning, these guys look way far apart. We're measuring frequency. We can see it and we can hear it. When we get to an equalizer, we say things like boost the 5K on the hi-hat. That's 2K, there's about 5K. I'm looking at this number down here. Or we say, let's roll off the rumble of the guitar. The low frequencies under about 60, maybe we actually want to be more like 100, and then get rid of the low rumble of the guitar. Those are some examples of how we use frequency to enhance what we're listening to. As we developed the science of digitizing audio, a fellow named Nyquist determined that in order for us to get an accurate representation of the sound, we needed to record, or sample, at twice the frequency of the sound that we wanted to hear. If we want to hear all the frequencies in the sound, up to the 22,000 hertz limit of our ears, we should use a sample rate of twice that, 44K, 44,000 hertz. When we're making a new session in ProTools, the lowest sample that we can use is 44,000 hertz. We'll talk about this in greater detail later, but here's the simple answer. It's never quite black and white, but in the world of music, you're going to use 44.1. In the world of video, you're going to use 48. There are higher sample rates, and if your hardware gives you the option of using those, you'll have a higher quality recording. Your files will be bigger, and you may not be able to play your files on some systems. The new M-Box, for instance, can convert at 96K. You can downsample a 96K file to a lower frequency, but as Nyquist proved, once you chop off the higher frequencies, you can't get them back. The other parameter here is bit depth. Bit depth lets us perceive dynamic range, the louds and the softs. The M-Box gives us three options. Most people these days are comfortable at 24. Legacy sessions are more likely to be 16. So a 24-bit resolution is 50% higher quality than a 16, and that gives you a more accurate dynamic range. Pro Tools 10 added the ability to create 32-bit floating audio files. The upside is more accurate dynamics and no chance of clipping. The downside, though, is bigger files. Bigger files by themselves might not seem like a problem, hard drives being cheaper than they used to be. But if you have a session with lots and lots of audio tracks that need to stream in simultaneously, your hard drive might not be up to the task. Keep in mind that what you set when you're creating a new session is not retroactive. It can never be better than its lowest setting. If you want to keep it simple, 44.1 for music and 48K for video. When it comes to file types, there's normal wave and WIF, a broadcast wave file. The difference is chunks of metadata that are contained in the broadcast file. Vexed chunks and IXML chunks are helpful in TV and movie production, where each actor and each take and each camera would have different audio associated with it. Okay, let's get into the interface and see how all the science lets us be creative.